So binomial, bi means two. And binomial only works if there's something that has two outcomes. Like you either make the basket or you miss it. This is back when they were inventing basketball. It's one of the few sports that was invented in America. And they literally had a basket and a ball. And I'm not sure how they got it out of there once they did make it. Probably just like punch the bottom of the basket and ball pops out. Anyway, and there was no, if you can imagine, no backboard either at the very beginning. It was just a basket. You try to toss the ball in it. Anyway, you either make it or you don't make it. That's the binomial thing. So this will only work if there's two things, like heads and tails, or like making it or missing it. So we use a lot of sports analogies on this one. And here is the big complicated formula. We are not going to give you this formula, so you may want to write it down to start memorizing it for your test. Test is coming up at the end of this week, on Friday specifically. I've noticed a fair number of kids are going to be gone Friday. I don't exactly know what it is, but there's something happening. And if you're going to be gone Friday, you could take it Thursday, but that'd be really hard because there's a review day Thursday. You'd have to do this test without the review for the test. That'd be really hard to do. So if I were missing Friday on this test, I would just wait till Monday and then walk in and say, hey, can I take the test now? Or Tuesday morning, then you wouldn't even have to miss class. All right, so here's your formula. Now this looks kind of scary, but once we do a couple, you're going to understand and be like, oh, it's not that bad. All right, so let's make a sports scenario for this one. Most of you guys have been in sports of some kind. Let's say you're a soccer player. Would you agree that if you put the ball right in front of the goal, you're going to kick it in pretty much every time? But if there's a goalie standing there, now you're going to kick it in a smaller percentage of the time. Let's say that we kick a fixed shot from a certain distance. You can make it so that it's really hard for the goalie to block it. You might have an 80% chance of making it. All right, so let's do that scenario. This is make, and this is going to be miss. Now, let's say there's an 80% chance of making it. Then this is 0.80. Right away, you can see that this formula is going to become easier because you can do miss in your head, can't you? If it's an 80% chance you're going to make it, then there's a 20% chance you're going to miss it. I'm putting these in parentheses. Now, if you only had one shot, sounds like the beginning of a Eminem song. You only had one shot. Well, then you'd have one, and you want to make one. And your R would be 1 then, and your miss would be 1 minus 1, which really would be 0, because then you're going to have 0 misses. Anything to the 0 would just default back to 1, and then it's really just 0.8. We already knew that, though. That's kind of useless. If we had one shot and we want to make it, 80% chance. See how the formula would have worked, though, for one? But now, watch me set up one that's much more complicated. Now we're going to change to that same soccer player has got this kick with a goalie in between. Let's say it's a free kick. And we figured out that their chance of making it is 80% still. Put a C and 2 sets of parentheses, 0.80 and 0.20. And I think after we've set up a few of these, you're going to be like, oh, I get it. Now, it's very boring if we just take one shot because we already know the answer. It's a 0.8. So what's much more interesting, I think, is let's say you took 10 shots from there because it's like practice, okay? And you have an 80% chance of making it. Wouldn't you think you'd make 8 out of 10? Like, wouldn't you think that'd be a really high chance that you'd make 8 out of 10 if you had 10 shots? But actually, the problem is that do you get there is some other chance that you might make 9 if you're having a good day? There's a probability of that. And isn't there also a chance you're going to be just a little off, even though you should make 8 out of 10, that you might end up making only like 7 or 6 out of 10? All of those are things that are possible. So actually making exactly 8 out of 10 is not an 80% chance. So here's how I'd set it up. I have 10 shots, and I'm going to investigate. I'm going to choose to look at 8 out of 10. I'm trying to figure out the probability that I will make 8 out of 10. Are you with me so far on the 10 choosing 8? Do you get what's happening there? I have 10 shots, and I'm looking into the probability of making 8 out of 10. Okay? Not 9, not 7. I'm looking at probability of making exactly 8 out of 10. Well, then I would have 8 makes and 2 misses, right? Okay, that's how you set it up. Now, if you can type, you can get the answer. Use your calculator. 10 choose 8 is not simple to do in your head, so you're probably going to want to bust out the calculator. In case you forgot, it's under math and probability, if I was using the big kind of calculator. If not, if you're using the iPad's calculator, you're going to have to bust out the formula for that. 10 factorial over 10 minus 8 is 2 factorial with an extra one of these. 8 factorial, kind of a pain. I bet you wish you had your graphing calculator. You're going to say the same thing on the test day, so bring your graphing calculator. So I know there's a couple people who are just sitting there instead of typing it in. They're going to say, but my calculator doesn't work. Well, you could if you wanted one of these fancy kind of calculators, but you only had your iPad. You could go to single sign-on, log in there, and then pull it up that way. Brandon, have you got an answer? Mm-hmm. Excellent. Everybody, please take your answer. It's on a calculator, I would think. And would you please hold it out to the person next to you and see if you got the same thing as them. If you did, no more discussion needed. Would you read it to me, sir? 0.3024. Now, we usually go to 3 decimal places on the test. Would you agree that roughly there's only a 30% chance that you are going to make 8 out of 10 of those shots? Isn't that really weird? Most of you would have said there's like a 90% chance that you're going to get 8 out of 10 because you're an 80%, you know, like normal is 80% for you. So why aren't you getting 8 out of 10? Because there is some chance, like 0.193 or something like that, we could figure it out, that you're going to make 9 shots instead. See what I mean? And isn't there some probability you're going to make 10 out of 10? Let's say that that's only a 0.09, but if you add up all of these, and then isn't there some chance you're going to make 7 out of 10? Just barely miss your average? Yeah, that's probably a pretty high chance, like 0.253 or something like that. Do you get my point? There's a whole bunch of probabilities that would all add up to 100%. All right, so I think the best way to see that is for you to try to figure out the probabilities of a smaller number, like not out of 10. Okay, so let's just change the problem completely. New problem. All right, so get to a blank page. And this time it's basketball. Is there anybody in here who has played basketball at a high enough level that you actually know your free throw shooting percentage. All right, then I'm gonna just make one up. So let's say there's a kid in here who has an 85% free throw shooting average. 85% average. As in other words, if they shoot 10 times, they're gonna make on average 8.5 out of 10. Okay? Now, let's say, actually, you know what? Let's change it to 0.75. I have a cool reason for that. 0.75, sorry. 75% free throw shooting average. It's actually hard to get really good at free throws unless you shoot them a lot. All right. So if I write this for C3, 0.75, 0.25, can you finish it? That's part of the formula, but I skipped a couple things. There's a couple powers missing. And then put it in the calculator and see what it is. No doubt, kind of a pain in the butt to put in the calculator. And in case you missed the memo, this is your make percent. And how many did I want to make? I wanted to make 3 out of 4 shots. At the end of the game, if you're one of the better players, then you're still out on the floor in the last few minutes of the basketball game. A lot of times people will get fouled a lot in the last few minutes because they're trying to like have a chance to turn the ball over, and so they foul people and they go to the free throw line. There's a very real chance if you're one of the better players and you're out there, you're going to get fouled a few times. And let's say that you get 4 chances to make a free throw, and we're trying to figure out the probability you'll make 3 out of 4. Well, then you're going to miss 1. And that's what you should be putting into your calculator right there, if you haven't already. Would you please compare it with the kid next to you? See if you guys got the same thing. Andy, what'd you get?
0.1.
Okay, you definitely did something wrong.
Yeah.
Try this separately than the rest of it. Just find 4C3.
Wait. I put the power of 8 on accident.
Okay. All right.
Okay. Oh, I messed it up again.
I'll come back to you. Zeke, what did you get for the final answer? A little louder. 422. Raise your hand if you got the same thing. Nice. There's about a 42% chance. But isn't that weird? You got 4 shots. Your average is 75% chance. Shouldn't you be making 3 out of 4 like most of the time? We're not even going to make that. We don't even have a 50% chance that we're going to make 3 out of 4. Well, that's partially because there is a probability that you're going to make 4 out of 4. Would you please figure that out and put it right above it? I know that might mean you have to erase some stuff, but put right above it, put 4C4. And if you're smart, you don't even have to enter 4C4 on the calculator. It'll make sense if you think about it. But maybe you have to put it in the calculator to affirm that, oh, I guess it's just 1. But the final answer isn't 1. Ron, what'd you get for that one? Have you typed it in yet?
No.
Type it in. Everybody, please type it in. There's some things you don't have to type in, like that's just 1. And anything to 0 is also just 1. Right? Rohan, what'd you get? It's just 0.75 to the 4th.
I got 0.316.
Anybody verify 316? All right, good. Together, there's a 70, I'm adding them into my head quick, 73, or actually it would probably around a 74% chance. Ooh, 74%? Isn't that pretty close to 75%? Chance that you're going to make 3 or 4. See, they could do that on the test. They could say, what's the probability makes 3 or 4? Well, you figure out 3 and it's this, and you figure out 4 and it's that. 3 or 4? Well, you add them together. Ors are big answers. Been telling you that for a long time. You win if you have a cat or you have shoes on today. Well, it's pretty good chance you win then. All right. Or means add them up. So this would be a final answer if I said, what's the probability you made 3 or 4 shots? How about if I said 2, 3, or 4 shots? Well, then it's going to be way higher because you'd have to figure out this. I'm going to just write it really quick. You just type it. 4C2, go ahead, start typing. 0.75 to the 2, 0.25 to the 2. You should get fast at typing these because you're going to do it multiple times. A lot of times. 210? Anybody verify 210? Or 211? You guys think it's 11 or 10? 1-1. You're agreeing it's 1-1 now. Okay, good. Now if I said, what's the probability that you would make 3 or 4 or even 2? Well, then you just add them all up. Now I'm at like 93% or something like that. Okay, so, well, could you just figure out all of them? You could. Here's the one that they like to do. What's the probability you'll make at least 1? And the pain in the butt is that you're like, well, then that means you're going to make 1 or 2 or 3 or 4. But there's a much smarter way. All right. Just to show you what I mean, I'm going to finish this one. What's 4C1? Everybody type this one in. 4C1, 0.75 to the 1, 0.25. Must have 3 of those misses. And that's some decimal. 4C1, 0.75 to the 1, 0.25 to the 3rd. Who's first? Somebody got it? Yes.
0.047.
Anybody? I need to verify that. Yes, I'm getting multiple verifies of that. Good. Then what's the only thing we haven't figured out? Is there a chance you will make none? Yeah, and think about that. It's 4C0, and that defaults to 1. 0.75, you have 0 makes. So that defaults to 1. Then it's 0.25 to the 4th. Well, that's easy. It's 0.25 times 0.25 times 0.25 times 0.25. That's pretty easy. What is 0.25 to the power of 4? Now, we usually go to 3 decimal places for moments exactly like that, so that we wouldn't round to 0. If we go to 3 decimal places, what would we say? 0.004. Does that mean 4%? No, it means 0.4%. You always move the decimal 2 spots. 0.4% chance of that. Extremely low chance. Now, if I said, what's the probability you make at least 1, you either have to do all of that and add them all up, or do you get it would have been way smarter to do something else? Rohan.
Do 1 minus 4, 1 minus point.
Yup. 1 minus that. And I could do it in my head. I just saved you a ton of time on a couple homework problems and the test by reminding you when they say made at least 1, you don't have to do them all like this. You can take 1 minus that. It's kind of like saying chances of rain tomorrow are 20%. Well, what's the chance it's not going to rain? Yeah, it's just 1 minus that, right? Just take 1 minus all of the one thing we don't want. All right. Okay, so let's just make sure you really got this. New problem, completely new problem. Can you set it up right and everything? Let's say I said a nice normal one. Let's move to hockey this time. Let's say that it's a really long shot going in an open net. Okay? And you're at all the way on the other end of the rink. Okay? So imagine you're at all the way at the other end of the rink and you get to shoot with that open net. What's the probability you're going to make it? Well, for some hockey players, it's like 100%. So let's just say it's an average Joe, and they have to shoot a whole rink length and hit an empty net. Let's say that there's only a 85% chance of that. I know that might be really high, but maybe they're decent at hockey. Okay, so 85% chance of make. Then let's say that there's this big contest, okay? And it's like one of these, like, win a car if you can blah, 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 okay? Well, you got to make at least 5 out of 6 shots to win the brand new car. What's your probability of that? Hint, first figure out the probability of 5. It's really common to do the half-court shot in basketball. Could have done that too. You know, there's actually like little insurance policies you could buy, and then the insurance company has to pay out. There was a guy who made it from half court, and the insurance company wouldn't pay out because they did some research on the guy. Turned out he wasn't just a amateur; he was actually like a professional basketball player, and they had it right in their contract that we're not paying out if some professional makes a half-court shot. We're only paying out if this is an amateur. So they have little rules in there sometimes like that. I'm sure he still felt robbed. He was supposed to get like a brand new car or some really expensive thing, but in the rules it said can't be a professional. Because that would give you a huge advantage, of course. All right. Did you know to put a C in front and then 2 sets of parentheses? Did you put 0.85 here and 0.15 there? And then did you realize what I said was 6 choosing to make 5. 5 makes 1 miss. That's how you would start. But then Sommerfeld, did you get that answer? 0.399. Can anybody verify 399? Okay, good. Other Sommerfeld. What do I have to do now to finish this problem? Do you know? We just figured out 5 out of 6. Isn't that the question? No, it's at least 5 out of 6. You are correct. 6C6, which I already know the answer to. 0.85 to the 6th, which I can do on a calculator, and 0.15 to the 0, which I can do in my head. So really, I just got to do part of this in the calculator. Everybody get that? Just takes a second. Type it in. What is 0.85 to the power of 6? 0.3771. All right, cool. So what's the probability of making 5 out of 6 shots? Well, it's these two put together. They would lose a lot of money on this promotion because it's pretty likely this person's going to make 5 or 6 shots. Add them up. What is 0.377 plus 0.399? It's 0.776 probability. So it's a good thing we went through and figured out our theoretical probability. If somebody's good at hockey, they have a 75% chance of doing that. We better make the prize kind of small. because there's a pretty high chance they're going to win it. All right, it would be totally different if your make percentage was only like, I don't know, maybe you have to hit the puck using a, I don't know, teeny tiny little like fork or something. It's going to make it way harder to, hit it in, and now you only have a 5% chance of making it. Well, then making 5 out of 6 is really low probability, and then maybe you could make the contest like that. All right, so you've learned something called binomial. I want to get this homework started with you right now. And then I want to warn you ahead of time, tomorrow I have got a video all queued up for you about expected value, and I have to be gone, so you'll have a video and then a bunch of time to work. I know the video is good. I checked it. It'll cover everything you need to know. But here, let's start today's. Find today's homework. Notice that the key is already there. Totally okay to check the key to make sure you're doing it right. Now, for number 1, they're going to make you do an annoying number of probabilities, just like we just did. But it's really important that you get the idea of how these kind of like set up. So you should do number 2, 1 and 2 together. Number 3 is important, and we're going to work on that together. Number 4 is a complete repetition of what number 3 is like. So we're just going to skip number 4. And that's the only one we're skipping. It'll save you a fair amount of time. If it turns out you do the whole thing and you're like, crap, I got a lot of them wrong, you should probably go back and try number 4, because it's like good practice. It's just unnecessary extra practice. Okay, let's start number 1 to make sure you understand what's going on. An illusionist kit. Brandon, would you read an illusionist kit, blah, blah, blah?
Yeah. You find a weighted coin that is designed with a 65% probability.
Ooh. 0.65 is your make probability. It's like you make it or you miss it. You make what, though? Heads. Okay, keep going. All right. So it says 0 is under heads. And then it wants you to do the probability formula. That's that C thing. Well, there were 7. Choosing 0 heads. The thing we're focusing here on is heads. It's kind of like making it is getting a heads. Then this is heads. And there's a 0.65 of that. But I am making 0 of them. So it's 0.65 to the 0. And it's 0.35, because they have to add up to 100%, these two. And there must be 7 misses, so to speak. And this is where they want you to actually write the answer. So I'm smart enough to know that that's 1 and that's 1. So then I'm just going to do 0.35. What is 0.35 to the 7th? 0.0006433. Since I'm not sure where to round, I just thought I would just throw them all on there. Now, does it say where to round? It doesn't say where to round. So if I were you, I would put all of that in the blank. And teacher have a hard time saying, you're wrong because you were too accurate. All right. Then we do 1 heads. 7C1. 0.65 to the 1. 0.35 to the 6. I think you get the idea. Just keep going like that, finish that up, and then you answer some questions about it in number 2. If you haven't got all of the number 1 problem done yet, you can't answer number 2. All right. Now, I want to give you one problem that's going to be like tomorrow's lesson, because I'm going to be gone. Let me teach you one problem like that. But I know it's really hard to get kids out of their homework once I said you could start your homework. So would you please stop, take your iPad and turn it upside down so it's facing the desk, and just listen for a minute. Imagine I have 3 envelopes up on my desk. One of them has $50 in it. One of them has nothing. And one of them has $10. They are black envelopes. You can't see through it. You have no idea what's in there. Okay? Now, if it was free to play this game and you could come up and pick an envelope and you get to keep what is in the envelope, well, duh, everybody'd like to play the game. But it's not free. Let's say it costs $1 to play the game. Raise your hand if you feel like you'd be willing to play the game if it only costs $1 to play. Yeah, you're all raising your hands because unless you are against gambling or something, this is a good gamble. You're going to pay $1 and there's only a 1 in 3 chance that you get nothing, right? Okay. But what if I priced it at $15? Now, some of you that are more the risk taker types are like, oh, yeah, I'm still in. And others of you are like, nah, I'm starting to feel like that might be a little expensive. What if I charged $25? Most people are shaking their head, no, too expensive. Somewhere in there is the expected value, which is the exact fair price to play. That's what expected value is what would you expect? As in, what's the fair price to pay for this game? And then usually, do they charge you the fair price? No, they charge you more because they want to make money. Either it's a fundraiser or it's like Las Vegas where they definitely want to make money. Okay, so we figure out the fair price. I want you to take your best guess right now. Don't say it. Don't write it down because I don't want you to flip your iPads over or you'll just get distracted. Like Brandon, shut your iPad. Thank you. So you got a number in your head? What's a fair price? I'll tell you the answer in a second. Now tell somebody, what's your fair price? What do you think's fair? What do you think's fair? Okay. All right. Here's how you figure out the fair price. You take the probability times the amount plus the probability of this one times the amount you get, plus the probability times the amount you get. And you add them all up. So if you can just remember that for tomorrow, that actually works even in all kinds of other situations. You take the probability times how much you get for that thing and add it to the probability times how much you get for that thing. So it's P times A, and then you add them all up. That's how you do tomorrow's lesson. Now, you get a more official lesson, but that's what it's going to come down to. Probability times the amount. So let's do it. What's the probability that you are going to choose that envelope? 1 out of 3. What's the amount you get if you choose that envelope? 50. Plus, what's the probability you're going to choose that envelope? 1 in 3 times 0. Plus, what's the probability you're going to choose the third one? 1 in 3 times the amount you get, $10. And then what's 1/3 of 50? What is 50 divided by 3? 16.666, round, of course, plus 0 plus, I can do this one in my head, $3.33. Those of you that were picking about $20, you were pretty good. Because that rounds to $20. That would be the fair amount to pay. So when I was offering the deal where you would pay $15 to play, does that guarantee you a win? No. But it was still going in with, like, not being stupid. Your expected value was 20, so you paid 15, and on average, if you played the game a whole bunch of times, you would win on average. If somebody set up the casino game wrong like that and was only charging $15, then on average, you should play, on average, you're going to win over time. Okay. So P times A, then add them all up. That's tomorrow's lesson ahead of time. All right. That's all I got for you for today.